All right, so actually, if you've read the session description, instead of the promise talk that I held a couple of times in the past, I took the time and did a brand new one for this occasion here. So it's a bit less techy, it's a bit less code. I would call it a thought piece if I didn't despise that term to whatever. Instead of like really going down and showing how I've implemented protocols and what protocols for the smart home system are made of, I actually just want to share some of the pain and frustration we as implementers of smart home solutions feel, and hopefully give you a better picture about the state where we are now, where we're heading, and what this friggin' IoT smart home thingy is actually about. By the way, this is me. I'm Sebastian. I work at Deutsche Telekom as, I don't know, that they gave me that title, and probably just because they want to have like folding cards I can hand out to people. So it's long enough that it actually makes sense. I've been in development for roughly 13 years, and for the past 5.5 years, I'm only working in the IoT department of Deutsche Telekom for our smart home solution. If you have any questions, you can reach me via Twitter at AskADisco or via the old way, via email, question@askadisco.com. Don't go to askadisco.com. There's nothing to see. You see like how it is with private homepages. You never get them done. So I'll just left it blank. Actually, starting from today, I'm also not only a developer, I'm also responsible for developer relations. So in the future, if you want to play around with our SDKs, maybe get some hardware to play around with, if you have good ideas you want to implement, please contact me, because that is probably what I will do from today on, getting in touch with developers. As said, I'm working for Deutsche Telekom's smart home platform. It's still called KiwiCon, although this brand name will vanish in the future. And we not only built this product for Deutsche Telekom, we built a product that is actually a platform that integrates various smart home protocols and offer that as a white label solution to other partners, like KPN in the Netherlands or EnBW. So if you're a customer of EnBW and buy their smart home package, basically it's the same technology, it's the same hardware and software as we as Deutsche Telekom are distributing, or KPN in the Netherlands is distributing under their brand name. Before we actually get to the meat, I wanted to just raise awareness for a side project of mine, which is the Nightly Build conference in Cologne, happening on the 1st of September for the 4th time this year. And if you're into front-end-ish stuff, I think you are, because you're in the JavaScript track, it's might worth taking a look at nightlybuild.io. Okay, that is basically enough marketing. Let's get to the meat. I've recently, beginning of this month, I was in Seattle, and I grasped some interest in the history of Seattle. And I think that's the history of Seattle, at least for the 19th century, can be described as a huge failure. Why is that? You see, this is a picture of early 19th century Seattle, and basically the houses and everything, they are built directly at the coastline. And Seattle isn't directly at the ocean, it's what they, at a sound, what they call, we would call this fjord. But they still have tide there, so high tide, low tide. And back in the 19th century, there was no sewage system, nothing. So what did the people of Seattle do? They put all the trash, all the crap, and that they want to get rid of, and they just put it in the water. And that is no problem because low tide, yeah, perfect, everything is just just gone. And with high tide, the problem was everything just came back. And this is a picture a bit later. This is what they called a street back in the days. So nothing that we would describe as a street today. It was basically mud, and because of high tide, it was mud with litter and, how to put this, toilet products in it. You see those wagons here, they're basically drowning in the mud. And before, Seattle was like this big technology city with Boeing and Microsoft and Amazon. They were actually in the logging business. So not Kibana-style logging, more like log-stash logging. And so they had this great idea, like incrementally improving their situation. We have a lot of sawdust as a byproduct of our logging industry. And what shall we do with it? Yeah, let's put it on that muddy streets. We think that will help us. Actually, it didn't help. You see some like sawdust stains here. It didn't help. Basically, it looked like if you have chocolate pudding and put cereal in it, but it wasn't actually chocolate pudding. So yeah, the situation was really worse until most of the city burned down in a great fire. So 29 blocks, including the complete business district, they've just burned down. And because it's the US, all the houses were wooden and, well, easy target for the fire. But that actually gave Seattle a big opportunity. And the mayor back then said, I've gathered all the experts. We have a great plan. We're going to rebuild the whole city. We have proper streets. We have a proper sewage system. We'll build houses not out of wood. We will build them out of stone. And all the people in Seattle, they were very happy. They said, yeah, perfect plan. That's exactly what we need. How long will it take? And the mayor said, 10 years. And then all the people, I mean, like the whole business district burned down, and all the people who had businesses there were like, yeah, we actually can't wait 10 years for you to like build up the city from ground, and started to, build up their houses again. Not out of wood, out of stone, because incrementally improving, they've learned, but all the parts that actually belong to the city, so the streets, they haven't been touched in the early years. So basically, people rebuilt their houses, their homes, and their businesses, but everything, the infrastructure part, was as worse as it was before. But later then, the city actually executed the plan and built the streets. And they built them in a way that is safe for before the high tide. So Americans seem to be great with building walls. And what they've done, they actually built the streets on top of walls like 3 or 4 meters high. So in the late 19th century, if you were in downtown Seattle and wanted to cross the street, you actually had to climb up a ladder, 3 to 5 meters, cross the street, and on the other side climb down a ladder just to cross the street. So it's basically they built actually walls in the streets that were the streets. And I mean, it was super, so they have a proper sewage system built in this whole thingy. Perfect. But yeah, that was actually a horrible user experience. And what you see here is a picture of Seattle Underground, because what people then did was they adapted. Those are actually the basements of the houses, which are now the cellars, because like the first story or the second story sometimes now became the ground floor of everything, because people adapted and they had already built their houses. And that was actually their plan. So I've been down there. It's a mess. It's full with rats, and it's a pain to maintain for the city of Seattle, because it's like those were the streets before. It was never meant to be a cellar. That were like the ground floors of the buildings. And Yeah, it smells horrible. They even build, sometimes they build little tiny windows up in the pavements. So when you walk over them, you can basically see down back in the old city of Seattle at 3 or 4. There are actually 3 or 4 parts of the city where they did that. So why am I telling you this? I think in the smart home space, we're very close to the fire. Like if you compare that situation with the Seattle situation. We're very close to the fire. Some people, I say, we're like right in front of it. The big fire will vanish everything, the bubble will burst. Some people say, now we already survived the fire. Nevertheless, we as implementers, we have some very impressive and good ideas we wanted to implement and ship to the people. But technology and systems are not there yet. And we have unsatisfied users because mostly when you go out and buy a smart home today, what you expect is much higher than what you get. That's just simply a fact. People, our users, are unsatisfied. We have an ecosystem that is fragmented, like beyond everything you know. If you think JavaScript's framework ecosystem is fragmented, look at smart home protocols and vendors. It's a mess. The thing is, we as implementers, as people who build those solutions, we need to fire up our businesses. We are in the need to sell something today. And we can't wait for 10 years to like finally execute our plan and have something that we're all aiming at today and ship it to the user. It's just simply, it doesn't work. We need to have a more or less sustainable business today. And this leads to situations and to products that look like this. This is from AccuFree Homematic. This is Europe's most popular smart home, or I would say automated home system, especially popular in every German-speaking country. So they're basically not available in the UK or in France, but they sell so much here that they're actually becoming the most popular and most sold system in the whole European nations. Also, we've got things like this. This is FHEM, which is a Perl-based system. Who writes Perl these days? I don't know. Those people do. And you see, this is one of the most famous systems in the open source space that is used to control anything that is nearly controllable. You have people who wire up things who are never meant to be wired up, but they do it. So I think we all can agree, this as a user doesn't look like you really want to touch it on an everyday basis. Especially not if you target not the developers, if you target the real users, if you target your +1s or whatever. So I wanted to ask the question, what do we and I mean developers think when I say IoT, Internet of Things? We mostly think about this. We think about devices, we think about hardware, boards, and stuff like this. So platforms, protocols, whatever. This is what we as developers think of when I say, hey, yo, IoT. But the more interesting question is, what do we forget about? And most of the time, I have to say, it's this. It's the user. Because you've seen that solutions, you've seen the screenshots I've had here from the most used systems, and they're not very user-friendly. Those are highly technical. And in our space, this is a huge problem. We're building systems that actually that clash with the user, that build a horrible user experience for extremely complex systems, and basically making our target the experienced tech person as the user, and not, I would say, the regular human being. We are actually expecting from people to have a a deep technological background in order to work with those systems, at least for most. But what is at the core of inventing new technology? What is at the core of technology itself? Actually, if you think about technology, it should be invented to enable the user to do something. It should make hard things easy, and just easy things vanish in the background so that you don't even notice them. And in order to do that, we basically need to understand. We need to understand the two core circles that we're dealing with here. On the one hand, this is the technology. We need to have a deep understanding of the technology. And on the other hand, of course, we need to understand our target audience and what our users actually want and what we need to ship in order to enable all the regular users to deal with our system and to enable them to deal with complex technology in an easy way. So I'll give you a 3-minute crash course in smart home protocols. I'll actually have another talk, which I've included the link, which deals very deeply with the topic and especially security-related questions of a few smart home protocols. As said, I've included the link. I'll encourage you to watch it later on because there might be some surprises in it. But now, 3-minute crash course. Protocols and what they do to the user. Protocols, we have many. I don't know, I feel like a new protocol emerges every month on, I don't know, or maybe every week, because all that cool Kickstarter and whatever products, they start building their own protocol, proprietary, no standard. If there are standards, they mostly have like 11 sub-protocols, hello Zigbee, that are mostly incompatible with each other. And it's a shit show. It's basically, you probably know that XKCD, and this is exactly what we're dealing with. I literally can imagine like managers and developers in businesses like sitting down and it's like, yeah, we could use that protocol, but I don't like particular thing X, so we'll build a new protocol. We'll be better than the last one. And this is what we're dealing with all over. It's a shit show. Also, what this does to the user. The user basically has to use like one app per smart device that they're buying. So you have a NetAtmo that controls or that measures your room temperature, humidity, whatever. And you have a heating system, which probably could benefit from that information, but because they're speaking totally different protocols, bad luck. No way. So, what do we need to do? This is basically also, I'm not a marketing person, but this was the idea of the product we at Deutsche Telekom built, like to consolidate the protocols, which we can do to some extent. As said, I'm not a marketing person, so we're not really successful with it because we implemented like a handful of protocols and there's like a mountain of protocols over there which we can't speak or won't or will not implement because of licensing issues or whatever. And the thing is, with all that protocols, they're kind of like, they're very different. So this is my short what the protocol. A lot of smart home protocols, if we speak about Zigbee and N-Ocean and Homedic Bitcause and Homedic IP and whatever, they're basically transmitting in the ISM frequency band. ISM stands for Industrial, Scientific and Medical band. So it's basically used in other branches as well. They mostly transmit at 868 megahertz. So this is for Bitcause, Z-Wave, and some of the Zigbee protocols. Only true for Europe, because in the US and in Canada it's different. I also know it's different in Japan. So basically you can't go to the US, buy a Z-Wave or Z-Wave plug there and use it here in Europe. Doesn't work because different frequency. Of course, you have things like Bluetooth, Wi-Fi, Zigbee transmitting at 2.4 or 5 gigahertz. As said, I've included Zigbee twice there because Zigbee has 11 or 12, or maybe today it will be 13 sub-protocols that also transmit on different frequencies. Yeah, as said, shit show. Also, protocols, they organize differently. So you have star topologies for like Homematic, or systems like your Wi-Fi, where you have one router, one access point, and you connect to it. But if you look at Zigbee and Z-Wave devices, they actually build a mesh network, which has the benefit of extending the range, but has the cost of a high latency. And I've seen complex Z-Wave networks with 20+ devices break down because one node was removed and taking up to 8 minutes to rebuild the network until it was finally reachable, or every device was reachable again, because every device has its own routing tables and they need to adapt if there's something changes. And yeah, I don't say star topologies are better for this, because they have a limited range, and that is what a lot of users we have deal with, actually problems with devices, especially if they live in old houses, and also the Wi-Fi is crappy because of whatever is in the walls. And if you have a mesh topology, you can probably bypass that, but you have a high cost. Also, different discovery mechanisms. You all probably know UPnP, Bonjour. Those protocols like Z-Wave and Zigbee and Bitcoin, they implement their own discovery mechanism. They all work differently. For an implementer, if you wanted to have a common interface that can deal with all of these different protocols and their uniquenesses, yeah, it's horrible. All right, I'll have a little demo prepared. So regularly, I travel with lots of tech, but this time only hand luggage, so it's a tiny demo. I have an ocean light switch here, and I have this little Arduino fella with an LED attached to it. And what I want to do is I want to press that switch and have the LED light up, or not, so basically toggle the LED. Okay, let's see if that works. All right, we're in the terminal. I'll get to the code in a minute. I'll first start up this system. Okay. Oh, great. Yeah, give me a second. I'll go and mirror the monitors because that helps. So everything's plugged in. Okay. Displays, mirror, mirror, mirror. Hello, mouse. There you are. Okay, great. Yeah, I was just in the wrong folder. Good. So first of all, I'm starting a receiver that connects. Let me also start photo booth so that you can see what I'm doing. So I'll first start a server that connects to the Arduino via the Firmata protocol. Then I'll have a USB stick here. Oh, short cable. Let's see if we can get it into the camera. No, we can't. You must believe me, I have a USB stick here. Let's plug it out. That speaks the Ocean protocol. Plug it back in. Therefore, I'm going to start a second system, and that is what we'll start with. So let me bump that a bit. So this is basically the receiving end for the switch. Let's do this via cam. And when I press the button, you see there's something happening. There are incoming telegrams, which basically represent what the Ocean protocol sends us. So, of course, this is actually some binary blah blah gibberish that's coming on. But if we convert it to a string, it looks like this. And in this string, there's a lot of useful information. For us, the most important is the unique sender ID so that I can identify this device. And what we have here, which is for this light switch, the raw data that identifies the button I've pressed. So on the other side, I have the Arduino connected. And back to the video. And if I now press the button, the correct one, that was the wrong one, that was the correct one, you'll see I can turn off that LED. Pretty simple stuff. But how does this work? Okay, let's first unmirror the displays. That will help. Hello, mouse, where are you? Here we go. Okay. What is the code for this? It's pretty easy. So no security checks, no nothing. It's just like the basics to get this to work. First of all, what I've done to connect to the Arduino. It's basically the Johnny 5 library, which is the default you use for Arduino connections in Node.js these days. Not only Arduino, it also supports other boards like the Raspberry, Tessel, and one of the million maker boards that are out there. And I'm also creating a simple HTTP server which just listens to every request and toggles the LED on that Arduino then. So it's just a basic web server with a basic implementation of the protocol that in the end allows us to turn this LED on and off. And on the other side, I'll connect to that USB stick via the serial bus using a Node module called Node and Ocean. Also, you see just simply listening to all the stuff that is happening on that serial port. And if we receive the message from the correct device, because that is the unique device ID of that light switch, and if that is the button that is described with 3.0 or the button that is described with 1.0, so basically 3.0 is up here and 1.0 is down here, we'll just simply issue a GET request, and that will be picked up by a server and, yeah, toggle the LED. Simple stuff. I mean, if I go back to the schema I have here, it should be as easy as pressing the button and the LED lights up. Of course, you can just exchange LED with any type of light bulb or whatever that speaks some protocol you want. But actually, it looks like this. I'll have 4 computers involved in this operation. Well, I have even 6 if you would count the light switch as a computer too, because it has some processor and etc. in it. But what I need to do is I have a protocol-specific hardware piece, that USB stick, that basically receives the commands from the button press. I have some piece of software running on whatever machine, mostly nowadays it's ARM boards or whatever, that unifies this. In my case, it was just a simple HTTP GET command into a protocol that some other computer, could be in the intranet, could be in the internet, wherever, understands. That actually needs to translate this into the protocol that my device I'm actually wanting to turn on and off needs to understand. So I'd say we have 4 to 6 computers here involved in this simple, I'll press a button and a light turns up. And of course, if you have different devices with different protocols, you have to repeat this for every protocol you implement. And as you've seen, there are lots of protocols. Also, this demo, this wasn't smart. When I say smart home, I don't think about pressing a button and a light goes on. It's not even automated. It's manual interaction. Basically, we reinvented a very complicated light switch. There was, like, with 4 computers and lots of software in between, and also lots of potential points of failure. I know that because I have replaced every light switch in every bulb in my home with something smart. Yeah. Okay, so this is what I call the manual home. Not very far from where we're living today. But what we actually want is to automate stuff. So, I mean, like, we sure need the light switches, but when I buy a 500 euro system, I'll expect more of it than being a glorified light switch. I expect something like this scenario, where I can have a geofencing, so radius around my home, and if I leave that, basically the light turns off when I leave it. Don't demo that right now because I don't want to just run around the block just to see LED lighting up or, well, turning off. So no demo here. But in order to enable this kind of automation, we need another piece of software that takes care of this. I mean, not only that we need another piece of hardware, like a phone, or something that can that knows our position and can transmit it, we need more. We need something that we call a rule engine. And a rule engine is basically, yeah, like you probably noticed from other parts of software development, it's basically something where you can have rule templates that have triggers and execute actions based on it. So I have a demo here from a rule configuration of the Eclipse Smart Home system. That's an open source system based on Java. Our product is based on it too. So we're actually the most prolific contributors to the Eclipse Smart Home system. And okay, so what we have here, we have a simple thing like, I want to turn off the lights when I leave. So what do I need to do? I'll have a geofence trigger that is basically a binary type trigger because it was just leave or home, 1 or 0, true or false. I'm at home or not. And if I'm away, if the binary condition, the at home condition that is defined in that abstract whatever impl of the geofence trigger, if that says I'm away, I'm going to call an action, which is the turn off all lights action, which is, of course, a binary action too. So this is basically the most simple template that I could construct with the Eclipse Smart Home rule template system that enables me to turn lights off when some other actions, in this case, I'm leaving the geofence, triggers. And if you see this, and this is, I mean, like, this is the basic template. We're still missing like the real implementation. We're also missing concrete action template patterns, condition template patterns, and whatever template patterns here, which are piling up on this. If you see this, and this is not even complicated because we could also add something like, I'm not alone at home. There are actually 2 devices, or 3, or basically, I will have a reverse scenario. When I get back home, I will have the lights turn on, but I will have the lights turned on based on the current light situation. So, I mean, like, it doesn't make sense to turn off all the lights in the house if there's bright sunlight out there. That is not even included in this template. So this is a lot of pros, I'd say, for a very simple task. And if you see this, you probably know why it leads to something like this, a highly technical representation of the view of things. And this doesn't hide the technical complexity, it more or less embraces it. And here we are again. The average user is scared of that technical complexity. It scares them away from the systems. And at the moment, we need to manage very well which features we ship to them and which features we present to them, because we could do so much more, but most of the user base is not willing to deal with that complexity. So, to not repeat the mistake of climbing up a ladder to cross the street, like Seattle did, we need to go new ways and incrementally improve our systems. One possible simplification could be chatbots. especially, I don't know if you've looked at the average teenager these days. They're basically living in WhatsApp or whatever their messenger is called. That is actually the hip one right now. But what they're doing is they want to communicate also with technology using a natural language, which is also true for not only teenagers, but also for the average user. So what we found out was people want to use, when they're in their homes, not some weird technical terms to describe things. They want to use their natural language as they were talking to another person to steer those things. So natural language is the key. I mean, systems like Google Home Assistant or Alexa have proven this, even on a very low level, that if you simplify and naturalize the interaction with technology, it will be adapted. So chatbots could be one thing to do this. I don't care what the input system in the end is, natural language is the key. At least that is what we found out during the past years of research. So now we're getting closer to an actual smart home. Before that, we had manual home, we had automated home, but nothing I would describe as a smart home because there was no smartness. Those were all pretty dumb systems that just did whatever we told them, and maybe just with some badge rules to tell them when to do things. But we needed to explicitly tell them what we wanted them to do. And what I think is what we need, and what we're all aiming at in this sector, are empathic systems that react on the user. So people call this artificial intelligence. I'd actually like the term from Microsoft, cognitive services, way more. And also, Microsoft has some great services with super APIs. Again, I'm not working for Microsoft. I'll just love what they have in this space. Open APIs to test and try out. Like, for example, this one, a natural language interpreter system. So a system that basically can understand the meaning of sentences or complete texts given to them. This is pretty easy. So switch all lights to green. If you were like you're a developer, if you were like to code that down, you basically could just search in a text for lights, green, on, off, etc. But it can get more complex, and you need a highly sophisticated system to interpret texts. And this is basically a pretty cool thing where it just strips out all the keywords for you. And I'm using this in a lot of prototypes I'm building at work. I mean, as long as Deutsche Telekom hasn't opened their AI services, of course I will use them then. But what I wanted to say is that actually makes the hardware in the smart home space a joy to interact with, because I can just simply say, turn off the lights. Or even if we have gesture tracking or whatever, even in a more human way, like I'm just in a room and I can say, turn that light off. Like the same as when I was like talking to a regular person in front of me, I would never say, could you please turn off the light over at the sofa or turn it to green or whatever. I basically say something like, can you turn off that light? Not that I'm that commanding at home that I'll send my girlfriend over and say, yeah, turn off the lights. I mean, we have smart systems. We can do it with our phones when it works. But yeah, I think you're getting what I'm aiming at. So for my next example, I basically looked for something that separates a computer more than everything from a human being. And I think that are emotions. So understanding emotions for a machine is pretty complex, I'd say. And I will have a simplified example, how we can make this possible. Basically, the example is, or the question is, how can we make a computer understand our emotions so that we, for example, could embrace them. Yeah, if you're feeling good, you want to keep up that mood. If you're feeling bad, research has shown, if you present people who are feeling bad, or feeling down, moody, if you present them with a special color temperature or a different type of music and stuff like that, their mood actually lightens up. They start to feel better. And if we want to have a smart system that can understand us and our emotional situation we're in, we could actually help people feel better. So those things are tailored specifically to me. Like, I was looking for key points that determine my mood. And those are, let me count, 2, 4, 6 points I'll come up with. No, 5 points and the emotion that results. So if I have less than 4 hours sleep, I'm probably feeling bad. So there's less or more than 8 hours sleep, I'm feeling good. If my weight goes up for a certain amount, I feel bad. If it goes down for a certain amount, I feel good. And also, I live in Cologne, but 3 days a week I work in Darmstadt. So basically, I'm feeling better when I'm at home and not at work in Darmstadt. And also, if I smoke more than 4 cigarettes before noon, it's basically an indicator for me being a grumpy person. If it's less than 2, well, then mostly I'm happy. So I've collected that points I identified over 30 days for every day, and I've added a happiness or sadness indicator to it. Oh, actually that slide, we'll go back to that. I gathered the data by asking myself every day in the evening, how was it there? How did you feel? And I was like, good, okay-ish, or bad. And then I've had the data points I've collected over the day, and like the final mood that was that resulted out of it. So you might wonder, how did I recognize my video, the thing that I described as video happiness? Again, with cognitive services. I'll have a camera at my desk at home, and that camera is actually there. You see, that's the tree for cats I have in the office. Is actually there to observe the cats when I'm away, but it actually served the purpose of taking a picture in the morning of me. So this is me trying to look happy. And it actually was, by the cognitive services, marked as happy. So I didn't fail at looking happy for this demo. And you see there are other points we can have, like sadness or surprise, disgust, anger. That is basically me trying to look sad. That didn't work out. It seems like the systems say it's very neutral. Maybe a bit disgusted. I think I just look weird. But yeah, it's okay. It's my neutral face. It's not my sad face then. And oh, here we go. All the data. I used some node module called Fuzzy for this, which is not very sophisticated, but pretty cool if you have a few data points and a result to shuffle all that data points and to extract another key point out of it. So that's a pretty basic example to predict my emotion and to send it to some other endpoint. How did I actually, I wanted to have this automated and smart, not giving like manual interactions with it. So what I did was like getting the data from my Jawbone activity tracker about how much I slept this night. The weight goes from my connected withing scale that I have at home that transmits changes in my weight. Of course, location from geoposition. The video happiness, I used a simple D-Link Wi-Fi camera on my desk for this, and the D-Link outdoor camera to track actually how much I was smoking before noon, because the outdoor camera is mounted at a balcony. I go out for a smoke at the balcony, and I use image recognition techniques, so if there's a change, if there's a person actually detected on the balcony, it takes some pictures, sends them to cognitive services, and looks for keywords like smoking, cigarettes, etc., that are extracted out of these pictures. So I've basically automated everything that I only had in the end to put up my mood there, and then after I gathered those data points, that I'll finally have a result to work with. So I have a demo for this. Let's do this real quick. Let's do the simple way, which is basically executing the script you've seen before. And terminal, here we go. No, that's what I wanted to do. And this is basically just a script that iterates over all the data points in the CSV file I've shown you. And in the end, let's bump this up a bit. In the end, predicts my emotions based on the current factors I collected for day. Those are stored in a variable test here. And of course, if you see I've slept more than 8 hours, my weight got down. I'm away, not at home. So at home, I feel mostly comfortable. But I'm in Berlin, so I'm away. And video happiness is mid, so I'm a very neutral video happiness person today. And cigarettes before noon seem to be less, so not that much. So in the end, it predicted from that key factors that I'm very happy today, which I kind of are, because I'm standing in front of you. OK. So we'll have to hurry a bit. With smart computations like this, I think a native language interpretation, more or less invasive concepts, or less invasive concepts, we can actually bring that smart home to the next level. This is what we're working on, which is not out today, or in some parts out today, but will, I think, shape the future of the smart home space, being as less invasive as possible by providing a higher outcome, being as user-friendly as possible, enabling, actually building hardware and software that enables our users, and basically lets us leave that glorified light switch, overcomplicated light switch I've shown you behind. I mean, we still need it. We still need the light switch, but maybe we can find better ways to know when to turn on the lights and to which temperature or which color to turn on the lights to actually improve our lives beyond the glorified light switch. If you want to know more about this topic, I mean, there was a brief introduction in 45 minutes. I've written a piece on it in German for the IoT magazine, the IX Developer Special IoT thingy that came out 1.5 years ago, which covers more of the open source system and the protocols. I've also done a couple of talks about this in the past years. If you want to look at the talk I was actually wanted to give here today about the deep protocol thingy and how to implement protocols and how protocols look from the inside out, look at the OMA IoT from the JS Camp Romania from last year. The others are mostly fun talks, which are now, I don't know, that one is, I believe, 4 years old, but was me tinkering with gesture recognition and stuff like that. So I'll encourage you to have a look if you're interested in the topic. Also, usual slide, we're at Deutsche Telekom, and especially in my team, we're hiring. We're currently evaluating building our next smart home app using React Native, and as you are in the JavaScript track, this might be of interest for you. So I'll be here around all day. If you have questions or questions about this, yeah, just come over, please. And you will have sources and links. Slides will be published, so you'll have everything ready. And one last thing before we'll end this up. If you're going to implement software, that works in front of users, systems and hardware that works in front of users, just one thing. Please don't be stupid. Don't be like Seattle. Do it right. Thank you.